we have to show the proof here. So let me take a loop. This is a loop. The resistance of the loop, there's a length A, B, C, D. It's a square loop of side length L, where the resistance of different arms are different. So 2R, this is 3R, this is 4R. What is the total resistance will be 10R. Let B bar be into the plane. Let it vary with the time. Then, now first, what is the EMF induced in the loop? We know Faraday's law. What is the EMF induced in the loop? E equal to S dB by dt. So this is S is what? L square dB by dt is B naught. All of you just go for this. In books, we have only theoretical statements. I'm giving one example so that it will be easy for you. So once you get clarity, it's all about logical doing problems. That one. Conceptual clarity is first for what is needed. So there's an EMF induced in the loop. How much of EMF induced in each side? Next question. So where you are going to place this E, net E? Because we did that one only, no? What all that EMF generated, that we assumed a cell, no? Where I should place this cell? Sir, wherever you want, the answer is wrong. It's not like that. What is the EMF induced in each side? Why, sir? Why you are bringing EMF induced? Let's go back to the induced electric field formula. So what is that formula? So the formula speaks like this, no? E bar dot dl S dB by, or say S dB by dt. So what is dB by S dB by dt is nothing but net EMF induced. Or shall I write? I'll write it only this one. So the EMF induced is proportional to length. So whatever the length of all the sides are same. So in each side, EMF induced will be 4 times of the net EMF induced. So this will become B naught L square by 4. So what you should do, don't bring this cell anywhere. In each frame, what happens, you should introduce a cell. And then according to Lenz's law, the direction of EMF induced to be positive, negative flux increases, d phi by negative, EMF induced positive. So therefore I'll give polarity like this. This is the EMF induced in each side. So this is R, 2R, 3R. This is 4R. There's a method. Huh? Sir, how you can do like that? But sir, you didn't do earlier. That's why I didn't discuss any problem based on variable magnetic field. I didn't do any circuit, that one. Only one problem I discussed where magnetic field is varying. That what when I didn't try to draw that one, just only equivalent circuit only to get the current I drew. So we should not treat, there's a totally different, magnetic field varies, no, you have to be very careful. So there's a method of showing the circuit. You should not draw, there's a wrong. Now you solve this. One student has put the net EMF in the side AB. Other student will put. Different students, when they calculate potential difference, they'll get different answers. Then who is right? All are wrong. This will be the method. Any reason for that? The EMF induced is proportional to length. This what here. E proportional to DL. Keep this. Then let's calculate the current. What is the total current? Total current is I is equal to E net by the net resistance. What is the net resistance? So this will be B naught L square R plus 2R plus 3R plus 4R. This should be B naught L square 10R. So let's write the potential differences now. Now what is the basic, the current or the induced current will flow. This current is due to what? Not due to potential difference. This current is not due to potential difference. That I can show proof now here. and we have a idea like this plus minus conventions. Okay, let's write potential difference VAB. VA minus IR plus E side minus VB equal to 0. What is I into R? I into R should be B naught L square by 10. Net EMF induced should be, oh, yeah, this should be net EMF induced in each side will be B naught L square by 4. Anybody value VAB? Anybody give value B naught L square? 1 by 10 minus 1 by 4.
3 by 20.
3 by 20. Yeah. 3 by 20. Yeah.
Minus 3 by 20.
Minus 3 by 20. Now look at that. Negative sign also indicated. We know current should flow from high to lower potential. No? Look at here. Moving from low to higher potential. Let's further calculate VBC. VB minus I into 2R E side minus equal to 0. Just help me with these values. Huh? VCD. Just share these values. VBC.
Minus 1 by 20.
Minus 1 by 20. 1 or 7? Minus 1 only? VBC is minus 1 by 20. Okay, fine. Last VCD and VDA.
Plus 1 by 20.
Plus 1 by 20.
Plus 1 by 20.
Plus 3 by 20.
Plus 3 by 20.
Will you say this current is due to potential difference? Quite meaningless, no? From A to B, current flows from low to higher potential. For C to D, current flows from high to lower potential. You can adjust values here, the R in such a way that potential difference will be 0 and current will be flowing. I think the idea of potential difference is 0, no? So what are this current is flowing not due to potential difference, due to induced electric field. And that field is what? Non-conservative. Because if it were conservative, work done in closed paths should have been 0, but it's non-zero because the heat is generated. Then from where that heat has come, the conservative field only does work, and work done by it non-zero. That's why some energy is available in the form of heat. So no, sir, VA at lower potential. So like VA is less than VB, but still current flows. VC greater than VD, current flows. So not due to potential difference, no. So the current in the, what is the conclusion? Note current in the loop flows due to induced electric field, not due to potential difference. So it's quite meaningless. I'll calculate potential VAB. It's of no use. Just for your mathematical purpose, you have calculated. So all these things are of no use. stupidity. It's quite meaningless to discuss all these things here. So that induced electric field is responsible. It will only push the charges. It will only drag the charges. So now first thing you encountered here. So what is that EMF induced in each side? And again, we should replace with a cell, no? So where to bring that cell? No, don't bring that E net in any one side. The EMF, the net EMF induced output should be proportional to length. I took a square loop, that's why 1/4 should be kept on one side. So there's a method of solving the problems here. No? Okay, from tomorrow I'll continue from here. So non-conservative electric field, this is what I'm giving proof. Rather than giving statement, I'm just giving one situation itself where you can readily accept that it's a non-conservative. So the charge flowing inside a loop where magnetic field linking it varying with the time is due to induced electric field, not due to potential difference. Okay, sir, but what about if flux varies? Here also flux varies, but we did all motional EMF problem. Then what was flux was varying, but B bar was constant. So when this idea of induced electric field will come into picture, only B bar varies, not like when flux varies. We took earlier some problems where B is constant. There also flux varies, but there again the current will flow due to potential difference. But here open the current will flow not due to potential difference. Getting the difference. That's why the name chapter name itself electromagnetic induction EMI. This is the main cause for that EMF induced. Tomorrow we'll continue from here. Thank you all of you. Any doubt related to this you can ask me today. I'll wait.